Hello. So today we are going to go over Unit 2, Day 1 notes, which is determining if something is a function. And as you can tell, I have already wrote out what the definition of a function is. Basically, a function is a special relationship where each input, the x, has a single output, the y. So I like to make the connection between a vending machine and a function because basically a function is a vending machine. So the idea behind a function and a vending machine is you input a code and out comes an item. So one code goes directly to an item. That's how a basic vending machine works. Now let me give you another scenario. What if we have two codes that go directly to one item? That also works, okay? I don't see why the vending machine wouldn't work if we had two different codes that go to the same item. Okay? But here's the problem when something is not a function. What if we have the same code going to two different items? How does the vending machine make that decision? A vending machine is very linear, okay, very straightforward. You put a code, you get an item. Simple as that. But what happens if you have one code that goes to two items? That's a problem. A vending machine is not meant to make that type of decisions. So that's where the idea of something that is not a function comes because it's not functional. The vending machine won't be able to make that decision. You can't type in a code and expect the vending machine to make a decision between two items. That's not functional. Okay? So now, for today's lesson, we are going to determine whether graphs, tables, order pairs, or mapping charts are a function. Okay? So let's go ahead and start with the first section, which is the bubble chart, also known as mapping charts. Okay? So basically, we're determining whether something is a function or not a function. Now, very important, if something is a function, all x's are different. If it's not a function, all x's are the same. Okay? Because remember, if we have one code, the same code going to different items, that's a problem, okay? We basically want one code, one input to go directly to one item, okay? That's the most important part, okay? So now, let's start with number one. Looking at all the x's, remember, x's, and let's go ahead and write this down just so we won't forget. X's is the same thing as inputs. And Y's is the same thing as outputs. Okay? So now, this input means X, output means Y. Now, is this a function or not a function? Well, if you look at your x's, are your x's different or all the same? They're all different. 1, 2, 3, 4. So because they're different, this is considered to be a function. And I'm going to write down the explanation as to why each item is a function or not a function, just so we can be clear. Okay? So basically this bubble chart or mapping chart is a function because all of my x's are different. Okay? Now let's look at number two. Looking at the inputs, also known as your x's, are my x's different or the same? Well, at first you might say, well, they're all different. Well, is it? With a bubble chart, you need to make sure that each number has one line coming from it. This number 1 has one line coming from it. This number 2 has one line coming to it. This number 3 has one line coming from it. But what do you notice about the 4? There's 2 lines. So that means if you were to type in the number 4 into your vending machine, this vending machine has to make the decision between item number 1 and item number 3. That's a problem. That's not functional. So the answer is not a function. Because input 4 goes to 2 outputs, aka x's are the same. Okay? So basically the first one, my x's are all different. Second one, x's are the same. Okay? Moving on. Now let's look at tables. Determine if something's a function or not a function. Well, let's look at my x values, my input. Are they all different? Yeah, they are. So this is a function because all x's are different. Okay. Number 2. What about this one? My output. Are my x's different? No, they're all the same. It's 1. So this is not a function because all x's are the same. Okay? Now, it doesn't matter if only 2 of the numbers are the same. If 2 of the numbers are the same, it automatically becomes not a function. For it to be a function, all the numbers have to be completely 100% different, okay? So now, let's go ahead and flip to the next page, and let's do another example of a table. Now, looking at this, is this table a function? Well, no, it's not, because if you notice, your input has 2 of the same numbers. Right there, it repeats with the 4. So right there and then, it automatically becomes not a function. Because not all x's are different. Okay? Moving on. Now, we're going to be looking at order pairs. Now remember, an order pair is just basically x and y. So the first number is your x, and your second number is your y. So in other words, your first number is your input, your second number is your output. Okay? So let's determine, are all my x's different? Well, there's a 6, there's a 4, there's a 6. There it is. It repeats. That's all I need for it to repeat once. So because the x's are not different, it's not a function. Not a function. X's are not different. So all the x's have to be different for it to be a function. Okay? Now the next order pair. 5, 3, -2, 0. This is a function because all x's are different. Okay? Now, when you're trying to determine if something is a function and you're looking at a graph and you're looking, let's say for example, this problem, we're trying to determine if this problem is a function or not. Anytime you're dealing with a graph, you have to do the vertical line test. Now, vertical line test is also known as the vertical pencil test. Okay? So basically what that means is if I were to put my pencil down and I move it anywhere on my graph, left to right, And remember, your pencil has to be in a vertical form, okay? Up and down, vertical, up and down. If I put my pencil down, as long as my pencil does not touch the graph more than once at a time, then it is a function. So let's start with number 6. If I put my pencil down in a vertical form and I move my pencil left to right, as you can tell, my pencil only touches that line once at a time. Anywhere I put my pencil, I'm only touching it once at a time. Okay? So that means this is a function, because that vertical line test tells me that all of my x's are different. Okay? Well, let's see something that is not a function for the vertical line test. If I were to put my pencil down for number 7, what do you notice? I'm touching my graph twice in multiple places, no matter where I move my pencil. Well, if I put it here, I'm touching it there and there. Here, same thing. Here, same thing. Here, same thing. You see, I'm touching that sideways U at 2 times anywhere I put my pencil at. So automatically, that tells me this is not a function, because all of my x's are not different. In other words, they're the same. So that concludes today's lesson. If you have any further questions, please do not hesitate to ask me tomorrow in class.